I recently bought this carport from a local auction. I want to set it up at least temporarily in the driveway to finish an automotive project I've been working on for a long time. I've got a pretty serious off-road camping Ranger that is like 97% finished, and I want to use this to help me work on it, get it to 100% out of the sun and protect it from the rain. So we're 20 by 20 feet, and I believe it's 10 feet tall at the sides and then 12 feet in the center. So nice and tall, open sides for easy access. Comes in this big old crate. Costs right around $1,000 all told, with taxes and everything. And I think that's a decent value, but we will see. So I'm going to take a perusal at what's inside the crate and take you through the steps that it takes to build one of these carports. And here's what you get: a bunch of galvanized posts and supports, and of course all these panels for the roof, along with all of the hardware. Glad to see that those have the seal around them. Is it too optimistic to find instructions in here? I don't see them yet. Maybe it's time to take these roof panels out, set them aside, and see what I really got. Roof panels removed, stacked in the driveway, and boy, don't underestimate that. Quite a job. Here's where we got cabling. Better view of hardware. Still no instructions. This could be a choose your own adventure. Let's say even poorly written instructions would have been better than nothing. At least then I'd have the choice not to follow them. Here it is, mostly pulled out in the driveway, and you start to kind of understand what's the plan here. There's a lot of items that you have a quantity of 10, including these uprights. I believe these are the parts that go on the ground and the bases for the uprights. So there's 10 of those, and then you end up with 10 of those tubes, and 10 of those tubes, 10 of those tubes, and 10 of these, which make the corner of the carport. All of these, I believe, are for making joints between the tubes. They slide in, get bolted in two places in this case. In other places, you've got tubes that only take a single bolt. I think these are actually diagonals for bracing, as shown in the picture on the side of the crate. So even if I can't come up with some instructions, I think I could build it just from the picture here. Here's the complete kit. I went ahead and just cut off the instructions from the crate because that's most of what I've got to go on. Although I did find, by searching on MSC 2020F, I found some other models from other supposed manufacturers that are very similar, not exactly the same, but I think their instructions are going to be good enough. So I'm going to go start trying to figure this out. Okay, here's the layout of the main tubes that lay on the ground on either side. A lot of these parts are the same, but some are reversed. Like there's two of these with the tab on this side, and two with the tab on the other side. So I've arranged to have them on the inside. But in any case, those connect to these intermediate pieces, which are offset. That was a little bit confusing, but the offset is made up for by the short extension. So in the end, measurements are your friend. So you obviously zero, we're at 5 feet, 10 feet. Here's the extension piece, 15 feet roughly, and then just sort of 20 feet. So I'm gonna call that correct. Of course, there's two different size bolts. They're very close. There's a whole bunch of these, and then fewer of these longer ones. Of course, washers and nuts fit both of them. I think from trying things out, the small one will go through the main tubes with a brace in between them. I think these longer ones are for doing the exact same thing. Brace inside on a main tube with the addition of a brace on the outside, and that's why it needs to be longer. Working theory, at least. The shorter bolts fit through with a washer on both sides and a nut, basically the perfect length. Okay, I figured out all the pieces and their arrangement into a single arch or a single truss. So here's the layout. So I've got this angled up because that's one of the ground pieces. But if you plug it in with this tube, which is right at 35.5 inches, and combine it with one of the bent arch tubes here with the short end on top, long end on the side, you end up with about 8 feet 6 at the arch where the bend begins. So definitely shy of the 10 feet that's advertised for the shoulder height. That'd be all the way out here, but I think that's how that's meant to work. The bent arch piece needs to have its short end up top, long end on the side. There's a brace that goes between them. The braces have a single hole at each end, and that's 39 inches. Going further, this is your longest double hole tube, and it is 71.5 inches. So one of those is going to be on each side of the arch. connecting the angled corner pieces to this center arch. Between the center arch, there is another brace. It's at almost 55 inches, and it's going to attach to the junction here using these two bolts and the third one that's on the arch itself. And that's what these matching plates are for right here. So the way I did this is I just figured out every tube that I had 10 of them. I grabbed 2 of each of those tubes. That's what I considered that I had to work with. The final tube that's a little confusing is this one. It actually makes perfect sense once you realize there's 4 of these. So these are for going down the ridge of the roof. 5 of these trusses, so that means there's 4 open spaces between them. Again, a single tube or a single hole, almost 57 inches. That's going to be attached with this right angle bracket here. So drop one of these in, and then the ridge brace will go something like that. And the width of the entire carport is right at 19 feet 9 inches, so a little shy of 20 feet as expected. Main surprise here is the height of the walls. I really thought that was going to be more like 10 feet to the curve, and it's much shy of that. So may need to install a lift kit underneath the ground tubes if you need that extra height. So here's an example of where I'm putting the reinforcement on this corner, and I'm using short bolts for all of these. My working theory is that a bolt or a nut has to be accompanied by a washer if it's on the center of one of these tubes. You want to spread out that load, otherwise you risk denting and crushing the tube. So I've used washers on the underside of all these joints, but on the top where there's a plate here, I'm counting that as the big washer, so nut goes directly onto that. Whereas here, I've got a big old slot, so I'm making an exception and putting a washer on both sides. That works out fine because this is a thinner tube. I can't fit a washer on both sides, plus a plate, plus a nut on these main big tubes. That kind of answers the question of what are those big long bolts for? There are 8 of these brackets along the ridge line because you've got 4 sections in between 5 trusses. So if you've got 4 sections between trusses, that's a bracket on each side, 8 brackets. Each bracket, 3 bolt holes. I'm thinking they want you to put a bolt with a washer through the big tube into the bracket, and a washer on here and a nut, and do the same for the ridgeline tube. And those are a little bit thicker than these trusses. So 8 of those connections times 3 bolts would be 24, and they gave me 23 of these long ones, so that's just probably close enough, or maybe I misplaced it and it'll turn up somewhere. Okay, most of the connections are made on this single truss. The one I haven't made yet is to this lower extension on the wall, and what I've done is squared it up with the measuring tape, measured first up here at the point before it starts bending, got 19 feet 9 inches exactly. That's what these joints basically push together, but not bolted yet. And then set this to exactly the same, 19 foot 9 inches here. So that will make this a square assembly up top, and then I'll add on these bottom parts and assume that they'll just find the straightness that they need to. And of course, this whole thing can be bent and massaged a little bit if needed to fit final placement on the ground. And of course, the final rule is, measuring corner to corner on the ground. That tells you you're square on the ground, and then you measure obviously between the 2 feet to make sure you're the same width. But all that will be handled later, and I think there'll be enough room to kind of bend and tweak this as long as it's very close when I bolt it all down. If you're the type of person who likes to modify tools to make a job easier, 14 millimeter wrench, cut and re-welded, can be pretty handy for a lot of things, especially this job. This actually was made originally to adjust, I think, valves on a old early 80s Mercedes diesel, but I'm glad I kept it. Slide it right underneath there, give it a really good Douglas. Just like I thought, there's a lot of compliance in these tubes, so even with these tightened down quite a lot, I'm grabbing it at the end, and I can easily move this in and out a few inches by the end of the tube. You can see it hinging up there. I wouldn't expect those to actually lock up firm. Once it's all set up with the roof material screwed down and attached on the bottom plates, I think that's where it gets rigid. Here's the idea I've got for raising up the first truss. I've got it connected up to one of the ground mount tubes. In fact, this is one of the ones on the outside, so this would be the end tube, and then the next one is about 1 foot from the end of this ground tube. And I think with that arrangement, I can literally lift it up from the center and set it down, and it'll have support. Less over here, but lots over here. I think it'll hold itself straight up even on a little slope that the driveway has. Best idea I've got. Well, things are going all right. I've got the 3 middle truss assemblies, if you will, attached to the base tubes, and then I've got the ridge tubes attached between them. For the ones on the end, I'm gonna have to do things a little bit differently. I think what I'll do is install one of these. Oh, hey kitty, how are we doing? I'll install one of the end wall pieces onto here, and then build the main arch, the main roof section, down on the ground, and I think that I can carry it up the ladder and then insert it into the wall section, which will already be standing. So it's going to take a little bit of time, but I think that's going to work. I've got a new mobile lifting platform. The ladder on top of this trailer makes me tall enough to more easily put up that top section of the truss on this last section of the building. And I think it'll also help with getting high enough to come down and screw in the roof panels, but we will see. Well, I want to get these base tubes nice and level on what is a very unlevel driveway. So the way I'm going about that is to clamp a 2x4 at either end, and then using a chalk line, not for its chalk, but just to act as a reference. And then I'll show how I lift and insert temporary shims and space it against the line so that it's reasonably straight end to end. These are temporary shims for now. I really just want to get it straight so that I can install the roof, all those panels screwed down with everything being square and plumb, and then I'll come up with a different method for finally securing this to the ground. I can just use another 2x4 as my guide, and either a pry bar to pull it away from the wall, or a hammer to get it a little closer and just nudge it up against that line. So I'll do that all the way up and down, and that should get it reasonably straight from end to end. For vertical alignment, I'm using one of my favorite tools, which is this Viking arm. And it's a little hand-powered lift that lets you go up or down with quite a lot of precision. And so I can lift it, lower it, and insert little temporary shims like this in strategic places. And then take the arm out, check it against my line, and see how I'm doing on vertical alignment. The sleeves that connect these vertical tubes and also the ground tubes are fairly loose inside the outer tube. So what I've been doing is going along, clamping a straight edge to the joint. This is actually the last of the ridge tubes that goes between the trusses. Coming along and just tightening the snot out of these bolts. In the end, I'm tightening them all to 12.5 foot-pounds. And I just kind of came up with that number on my own. That seems about good, but it does smash down the outer tube into the inner sleeve, and you could keep going and it would smash the inner sleeve as well, but this seems like a happy medium. Once I'm taking the brace off the alignment tube on the outside, they seem to be staying, but if they do change position, the long-term solution would be to weld something on the outside here, or even just clamp another piece of steel on the outside and securely screw it in. That would be in tension. The structure wants to collapse with the vertical tubes going outward. So a little strap on the outside here would be the fix for that. These are the anchors that came with the kit, and the unfortunate part is that they don't actually fit through the holes on the tabs that are included here. Now I could drill that out, but at the end of the day, this is still a pretty weak anchor. It's got a little bolt, and in this case, I'm not going into concrete, I'm going into this blacktop. So instead, what I'm using is another type of anchor called a strike anchor. And the concept on this is that you can drill a hole, you stick it down in there. This one does fit through the hole. You never have to rely on it turning to engage. Instead, you just strike this nail on the top, splits out the bottom while it's already in this case, the blacktop, and then you're able to put some force on here. The reason for these is just to prevent movement laterally, I guess, around on the ground. I just want this to basically perform in shear, not to prevent lift out. So I'll be drilling the hole and inserting an anchor. I guess I'm not sure which size I'm going to use yet, but I'll figure that out in mere moments. And this is just blacktop. It's probably only a couple inches thick. Interesting. That didn't look like blacktop material coming out, but so far I'm that deep. That's where it'll bottom out, and I'm happy with that. Let's get a little bit more of that dust out. Okay. And now we hammer on this nail. Oh, it slipped out at the bottom. Oh no, it's just going deeper. Not what I wanted. Well, okay, so now we have a new option, which I guess is to put the nut on here and have it split out with the nut already on it. To do this, I need a support under this tab because it is not very solid. Let's use the original sleeve anchor. Probably never going to use that. All right, there we go. So that sleeve has spread out down underground inside the blacktop. And actually the pounding has tightened this nut as well. So that's done. All right, on this corner, the tab is over real concrete. It's also the corner of the carport that's nearest the house where I can't put a cable down. So this is actually a place where I do want a bolt that actually holds this down. And so I'm gonna use one of these, I think called power stud, something like that. Anyways, it's your standard concrete anchor. So let's see how that goes. All right, so we're that deep. That is plenty. There you go. Put a little nut on top so as not to damage the threads. Cool. Yeah, so I guess I could have got a little deeper, but that's gonna work out great. Put the washer on. But now when I tighten this down, it'll engage the cone on the bottom of that anchor and lock it in. Oh yeah, it's getting good and tight, just like we expected. All done. So how do you actually get this thing square? Well, here's my contraption. Let me take you through it. The first thing to note is that the section of driveway I'm installing this carport on goes slightly downhill. And so that means that the ridge tubes at the top also want to fall downhill. That is, the whole carport kind of wants to tilt. So this middle strap connects to the ridge tube on that very end truss and comes back and connects to my car. And with just a couple ratchets on that strap, I can really precisely pull this thing towards me. And that takes care of the overall sort of parallelogramming that the sides want to do. So that was the first dimension to get straight. Next, I needed to line up these wall tubes so that they were all in alignment. And that really came down to pulling on this one that was a little bit of an oddball. So that's the strap from this top right point to the bottom left. By pulling on that, I was able to pull that tube in, and to some degree that pulled on the others around it, and these lined up nicely. So that was kind of the second degree of alignment. Next, even though the overall building parallelogram was handled, the distance between these wall tubes was all kind of, well, they weren't consistent, let's say that. And part of that is that the distance between the tubes on the ground, they're actually not the same distance even on that ground tube. So I had to measure those lengths. They're probably plus or minus an inch. And then I used this 2x4 clamp between the middle three truss tubes, and I was able to make those distances between the clamp sections match the ones on the bottom. So now I had basically a potential square. It was still kind of a parallelogram. I needed to pull it to make it actually square, but once I had the same distance top and bottom, I was able to then measure, corner to corner and match that to the other corners. Once those measurements were the same, I knew that was square. To help me do that, I measured up to the same point on each tube, made a mark, and then I could just measure from the opposing corner up to this mark and make sure that that measurement matched for this individual section here. And of course that measurement was different for the section next to it, but I was able to make these into squares. And also on the other side I did the same thing. Excuse me, I guess they're rectangles, but they are in square. All the corners are 90-degree angles now. So you can see I focused on just the middle two sections, if you will, of the four sections. There's 1, 2, 3, 4. I focused on the middle two, thinking that that's where I'll start with the roofing panels. So I can go up to the middle and start installing them, working my way down to the side, knowing that over on the other side and on this side, the sections are as square as they can be and in parallel with each other. Now, that's not 100% because after I realized that the bottom tube spreads, the distances between wall tubes, once I realized those were different, I also realized, well, the ridge tubes they gave me, they're all the same length. So above this point where my clamps are, things just kind of fit where they have to fit in order to make it all work. Those are not going to be perfectly square just because they're not the same length as the corresponding measurement down here at the ground. But this is as good as I could do. I think once I have the roof panels on those two center sections, I think that'll hold the things basically in the position that I have it in right now. All the straps can come down and then I can do the remaining roofing panels, and that'll make it strong enough for weather and everything. But in terms of getting it strong enough just to hold itself up while I finish the work, I think those two middle panels will do it. To get up there, I have the ladder on my mobile support platform here, and it's a little tricky to navigate all around all the different straps. I used to have some more, but it's manageable. So I'll get up there and I'll start installing those roof panels, hopefully from the top of that ladder. So we'll see how this goes. Well, it started out slow and it hasn't gotten much faster. What you're looking at here is a full day of installing these roof panels. It did work out well to square these middle sections on both sides, and that let me get started on the roof, mainly because with those in the position they needed to be, I was able to pretty easily manipulate the tubes on the very ends, the truss at the front and rear, to match where they needed to be. So everything is relative to these ones that I squared before, and then I just centered the roof panels with an even gap on either side of the truss that they attach to. Now, in terms of the order you put them on, like I said, this whole thing tilts downhill a little bit. So this is going to be the low end. And that means that I started with panels attached on this end truss. And then going forward, I'll call this forward, this direction, each successive panel laps on top of the one before it. And that way, the panel on the very end here is the topmost panel, and then the next one is on top of the next one, is on top of the next one, is on top of the next one. That way, if a raindrop comes down and it kind of wants to go this way due to gravity, it'll never encounter a seam. It'll always drop onto the next panel. Hopefully that makes sense. My self-propelled ladder platform has been working pretty well. I just drive back and forth to position that where I need to be, and now on this side I'm able to reach up to the last positions with the ladder on the ground. I started laying panels down the ridge line first, and then I've been working my way down to the side here. And that means that each rung of new panels has to slip one notch under the panel before it. That way the upper panels lap on top of lower panels, again, to keep rain from encountering a seam which would let it drip inside. This isn't going to be waterproof by any means, but to the extent possible, I'm trying to make it so that rain doesn't drip down inside. This side just needs some more screws for additional rigidity, and it's been nice working from a ladder on the ground, but I'll move the self-propelled ladder platform over to the other side so I can continue doing the installation on some of the upper rungs of panels over there. It took the better half of another day to finish putting up this roof, but it's all done and I'm pretty happy with the result. There was one change I made after the fact, and that is with these roof panels overlapping by one of these webs, they end up coming down to this point on the side. And I thought that was just a little bit too low. I couldn't easily walk underneath it without hitting my head, and it all just felt kind of claustrophobic over here. So I decided to raise this up. And the nice thing about these repeating patterns on these roof panels is that you can just slot them up as far as you want. So if you see up here, I made them overlap an additional 3, I believe, of these what I'll call webs or chines to get the height that it's at right now. Another thing I'm going to do is to double up these plates, these reinforcements. The thing is, these cross braces are thinner than the main tubes, and so I've got some thick washers on order that will spread out the load over the tube so as not to crush it, and will also make it so that this is centered and these side braces won't be forced to bend to make up that difference. That way I'll be able to really crank down on them. I think that'll add some more stiffness, which is welcome on this project. But for the price I paid, I think normally you'd have to pay about 2, maybe 3 times as much to get like a VersaTube equivalent carport, and anything at Home Depot or Lowe's is going to be in that range as well. So I think this was great value, and it's going to serve my needs, but definitely takes a little bit of extra ingenuity, creativity, and maybe some extra parts to make it all work the way I wanted it to, at least. Hope this was helpful to someone else that might have a big old crate of parts and no instructions, auction special that they want to get built in their driveway. Leave a comment if you've got a question, hit that like button if it was helpful to you. Thanks a lot for watching.